Okay, number 9. Okay, the first thing I want to point out about number 9 is that this graph is not differentiable at -1, right there at that sharp point. So if that sharp point had been in the middle of this interval here, then mean value theorem would not apply and we would just quit. But because the sharp point is at the end point of the interval, the mean value theorem does apply. Basically, it's asking us if we chop off our graph starting at -1 and ending at 1, maybe that's here, okay? If we use those two endpoints, is there a spot in between there where the average rate of change is equal to the instantaneous rate of change? And the mean value theorem is going to find that place right there where it happens. I kind of missed right there. All right, so that's what we're looking for. Yes, the mean value theorem does apply. So actual derivative equals estimated derivative. Actual derivative, 2/3, leave the inside the same, subtract 1, times the derivative of the inside, which is 7, and I'll smush that out in front and eventually turn that into a 14. Has to equal the estimated derivative, f of 1 minus f of -1, all over 1 minus -1. Now evaluate f of 1 and f of -1. F of 1, plugging in a 1 here, you get 14 to the 2/3 power, not very pleasant. F of -1, plugging in -1, we get 0, which keeps happening. All right, so now let's simplify what we have. Over here, I'm going to have a 14 on the top, the 3 is on the bottom, and the 1/3 power or cube root is also on the bottom, and it doesn't matter which way you write that. On the right side, filling in the f of 1, we have 14 to the 2/3 power, yikes, minus 0, all over 2. Okay, so we got a couple of other ugly things happening from here. So how do you want to handle this? Well, I think the 1/3 and the 2/3 powers are the first things that are standing out in my mind. At first, I'm tempted to cross multiply right away, but then I'm multiplying a 1/3 power and the 2/3 power, and I'm not really sure what to do with that, maybe. So for me, I think I'm just going to try to get rid of that 1/3 power, and I would get rid of a 1/3 power by cubing both sides, because remember, it's a cube root. So watch what happens when you conveniently just cube everything. Okay, if I cube the numerator on the left side, I get 14 cubed. I'm going to write it 14 cubed and hope it works itself out later. In the denominator, 3 cubed. And when I cube a cube root, that's just what's inside. On the right side, I have to cube all of that also. Well, when I cube the 2/3, that's a power to a power. You just multiply and you get 14 squared. On the bottom, I have to cube this as well. So we basically cubed everything on both sides, okay? Okay, so now I can see one way to get rid of those 14 squared and cubed. You could figure out what those are with your calculator or whatever. But if you cross multiply right now, I think you'll find an easier way to get rid of them. So I'm going to multiply by, I'm going to leave those 14 cubed and squared. I'm going to leave them the way they are. Okay, so I have 8 times 14 cubed equals 14 squared times 27 and times a 7x plus 7. Okay, now I hope you can see that we can divide both sides by 14 squared to make our work a little easier. Okay, the 14 squareds on the right side go away, and on the left side, the bottom one cancels, and there's still one left on the top. Now it's a little bit easier to look at, because now you just have to figure out 8 times 14. That's a lot more pleasant. So now we have 112 is equal to 27 times 7x plus 7. From here, it's up to you. Either distribute the 27, divide by the 27, whatever. It doesn't really matter. I'm going to distribute. Okay. 27 times 7 is 189. Subtract the 189. And I get negative 77 is equal to 189x. Divide by 189. I ran out of room. Divide by 189. divide by 189, and I get this ugly fraction, which if this was a free response question, you can leave it unsimplified. It's fine like that as long as it's correct. But since it's probably not a free response question, it's probably a multiple choice question. We need to find an answer that matches theirs. I got to see if I can simplify this. And I would try 7 or 11, okay? So it turns out that they're both divisible by 7. So divide them both by 7, and this simplifies to negative 11 over 27. I can see why I struggled with that one. That wasn't so pleasant.